You're standing at the edge of an African river. A lion drinks calmly on one bank. A crocodile floats motionless on the other, barely 10 feet away. Two of the deadliest animals on the continent, close enough to close that distance in seconds. Here's the uncomfortable part. Nothing happens. The lion finishes drinking, turns, and walks away. The crocodile sinks quietly back underwater. No confrontation, no violence, not even a raised guard. Two apex predators, zero blood. So let's actually ask the question properly. If these are genuinely the most dangerous, most capable killers in their respective environments, why does direct conflict between them happen so rarely that researchers studying predator behavior consider it a genuine exception rather than the expected norm? Because the honest answer isn't that apex predators are somehow peaceful or restrained by nature. It's that being an apex predator comes with a brutal, unforgiving mathematical reality most people never think about, and avoiding unnecessary fights turns out to be one of the most powerful survival strategies evolution has ever produced. Let's start with what actually defines an apex predator in the first place, because the definition itself hints at why this pattern exists. An apex predator is simply an animal that, as an adult, has no natural predators of its own, sitting at the very top of its local food chain with nothing above it. You'd assume that position would produce total confidence, a willingness to fight anything that crosses its path. The reality runs in the opposite direction entirely. Sitting at the top doesn't make an animal reckless. It makes it extraordinarily careful, because every single day of an apex predator's life involves a continuous, unforgiving calculation. Calories gained against calories spent. Injury risk weighed against potential reward. There's no emergency room in the wild, no antibiotics, no surgery. An injury that would be a minor inconvenience for a human represents something close to a death sentence for a predator that depends entirely on its own physical capability to eat. This creates a genuinely important distinction worth understanding directly, because the same instincts that make a predator devastatingly effective against prey work completely differently when the target is another apex predator. A hunt against typical prey is a calculated, relatively low-risk gamble. Fast, mostly predictable, and if it fails, there's almost always another opportunity tomorrow. A confrontation with another apex predator represents an entirely different category of risk. Even the winner of that fight typically walks away wounded, and a wounded apex predator can't hunt effectively, and a predator that can't hunt effectively starves. Evolution didn't respond to this reality by making top predators braver. It responded by making them extraordinarily skilled at avoidance instead. This is where the picture gets genuinely specific, because researchers studying predator ecosystems have documented exactly how this avoidance plays out across shared territory. Picture a single stretch of sub-Saharan African savanna, home to 5 separate predator species simultaneously: lions, leopards, cheetahs, spotted hyenas, and African wild dogs, all competing for space and prey within the same relatively confined area. If all 5 species pursued identical hunting strategies at identical times, the resulting competition would be genuinely unsustainable. Instead, something remarkable happens without any single individual animal ever consciously deciding anything. The ecosystem quietly divides itself. Lions dominate the cooler hours and open ground. Leopards, unable to compete directly, adapted an entirely different strategy, becoming skilled climbers specifically so they can drag kills up into trees, safely out of reach of both lions and hyenas. Cheetahs solved the same problem differently again, shifting their hunting specifically into the hottest part of the day, precisely when lions are too heat-averse to bother moving, trading ideal hunting conditions for meaningfully reduced competition risk. Wild dogs, smaller and more vulnerable than the others, adopted yet another strategy entirely, covering enormous daily distances specifically to avoid settling into any single lion-dominated territory at all. Researchers have a specific term for this pattern: niche partitioning, and it extends well beyond simple physical space into something considerably more precise: timing itself. In parts of the Americas, jaguars and pumas frequently occupy nearly identical territory, hunting comparable prey across comparable terrain. What prevents constant direct competition between them comes down almost entirely to scheduling. Jaguars tend toward daylight activity, while pumas shift their primary hunting into nighttime hours. Two apex predators effectively sharing the exact same physical space through an unplanned, evolutionarily reinforced timeshare arrangement that neither species consciously negotiated. One of the most well-documented examples of this avoidance behavior in action comes from marine research conducted off the California coast. Every autumn, great white sharks gather near the Farallon Islands specifically to hunt young elephant seals, with researchers documenting dozens of successful kills during a typical season. For years, the general assumption was that nothing in these waters posed a meaningful challenge to sharks this size. Then, researchers tracking tagged sharks began noticing something genuinely unexpected. On certain specific days, every tagged shark in the area would abruptly vanish simultaneously, sometimes staying away for weeks, occasionally for an entire season. The cause turned out to be killer whales, and notably not killer whales actively hunting or attacking the sharks, simply passing through the area. Tagging data showed sharks fleeing within minutes of an orca's mere presence being detected, even when that orca remained in the vicinity for less than an hour before moving on. Once sharks left an area, researchers documented shark-driven seal kills in that same zone dropping dramatically, in some cases falling to nearly zero. Two apex predators sharing the same water and the same prey, and one of them simply leaves immediately. No standoff, no test of strength required at all. Sometimes this avoidance takes an even more fundamental form, splitting not time or territory, but the physical environment itself. Consider a tiger and a crocodile occupying the same river system, a pairing that sounds, on paper, like an inevitable confrontation. In practice, researchers studying this specific dynamic describe it as almost a complete non-event. Tigers dominate the land, stalking through dense grass and forest edge. Crocodiles dominate the water, waiting submerged with barely a ripple disturbing the surface. They aren't rivals locked in ongoing tension. They're neighbors who, functionally, almost never occupy the same specific space at the same specific moment. Researchers describe this particular pattern as resource partitioning, splitting an ecosystem not by clock or calendar, but by fundamental environment, land against water, two entirely different battlegrounds occupied by two entirely different specialists with minimal, meaningful overlap. What makes this entire pattern genuinely remarkable is that none of it reflects conscious strategic planning by any individual animal. No tiger has ever specifically reasoned through avoiding water to sidestep crocodile encounters. This behavior became embedded into these species over countless generations precisely because individuals who ignored these boundaries simply didn't survive long enough to pass their genes forward. An enormous, ongoing evolutionary experiment where every failed trial permanently removed itself from the gene pool. Researchers using camera trap studies to monitor competing predator populations have documented something genuinely striking. These animals appear to actively track and respond to recent sightings of competing species, adjusting their own movement patterns day to day, based on where rivals have most recently been active, essentially reading and responding to an invisible, unwritten shared schedule. This still leaves one genuinely interesting scenario unexplained, though. What actually happens on the rare occasion when two apex predators do find themselves face to face, with no meaningful option to simply avoid the encounter entirely? Researchers who've documented these direct encounters describe something closer to a structured, silent negotiation than an actual confrontation, prolonged eye contact, stiffened posture, tensed muscles, every visible signal of readiness clearly displayed by both animals. And then, in the overwhelming majority of documented cases, one of the two animals simply turns and walks away. What looks superficially like a standoff functions, in practice, as a genuine exchange of information, each animal essentially communicating its own assessment of whether this particular fight would be worth its cost, and in most cases, both animals independently arrive at the identical conclusion that it isn't. What actually prevents these fights from escalating typically has less to do with raw physical capability, and considerably more to do with a shared, evolutionarily embedded understanding that conflict between genuine equals rarely produces a clean, cost-free winner. Only two damaged animals and a contested space, neither one ends up controlling any more securely than before. It's worth addressing directly why this pattern isn't absolute, because genuine exceptions do exist, and examining them actually reinforces rather than undermines everything we've covered so far. When food genuinely becomes scarce enough or territorial pressure tight enough, the calculated risk of starvation can eventually outweigh the calculated risk of direct conflict, which is precisely when documented cases of lions killing leopard cubs or wolves killing coyotes tend to occur exactly the kind of predator-on-predator conflict we've examined in earlier videos on this channel. These conflicts represent genuine last resorts rather than than routine behavior, visible evidence of what happens specifically once the underlying system of mutual avoidance has already broken down under genuine environmental pressure. Even within these exceptions, the underlying avoidance instinct remains visible in a different form. These confrontations overwhelmingly target vulnerable young rather than capable adults, and the aggressor typically leaves immediately afterward rather than remaining to risk a prolonged, evenly matched fight. Even the exception to the rule still follows the same fundamental logic: minimize risk, take the smallest viable conflict available, exit quickly. This directly contradicts the popular cultural image most people carry regarding apex predator conflict: two evenly matched titans locked in prolonged, dramatic combat until one finally, decisively falls. Researchers studying actual predator behavior have found this specific scenario is genuinely rare in nature, occurring far more consistently within edited nature documentaries and popular imagination than in verified field observation. The underlying reality is considerably quieter, considerably less cinematic, and, once properly understood, genuinely more impressive than the dramatic version most people already believe. Which brings us to the actual consistent thread running through every single example we've covered across completely different ecosystems and completely unrelated species. Apex predators didn't reach the top of their respective food chains by being the most aggressive or the most willing to fight. They reached it by becoming remarkably, consistently skilled at identifying precisely which conflicts were never worth having in the first place. A skill refined not through conscious calculation, but through an almost unimaginably long evolutionary process where every individual who got this calculation wrong simply failed to pass that mistake forward to another generation. Subscribe for more videos like this one.